Welcome everyone. Today we will be learning how to solve a system of linear equations using matrix method. So before we go ahead with solving the system of linear equations using matrix method, we should know what all we must know. First of all, we must know how to find the determinant of 2 cross 2 and 3 cross 3 matrices. We should also know the basic matrix multiplications. So let's go ahead with solving one of the linear system of linear equations which is there on the screen. So as you can see, we have three equations there: x minus y plus 2z equal to 3, 2x plus z minus 1 equal to 0, 3x plus 2y plus z equal to 4. The first thing we must notice here is that the variable terms must be on the left hand side and the constant terms must be on the right hand side. So the first equation, we can observe that all the three variables x, y and z are on the left hand side and the constant term, which is 3, is on the right hand side. So this is all right. But in the second equation, we can see that the variable terms are on the left hand side but the constant term is on the left hand side as well. So we need to move that constant term to the right hand side. So when we rewrite the equation, we will get the equation as 2x plus z equal to 1. So whenever such an equation comes where the constant term or the variable terms are not on the left hand side and the right hand side respectively, we have to move them. So now the equation is fine. The third equation is fine as well. We can see all the three variables x, y and z are on the LHS and the constant term 4 is on the right hand side. So this is fine. So let's rewrite the three equations once again. And when we rewrite the three equations, we will get the three equations as x minus y plus 2z equal to 3. And the second equation is 2x plus z equal to 1. The third equation is 3x plus 2y plus z equal to 4. So now we can start solving this system of linear equations using the matrix method. So the first step we need to follow here is that we need to find the coefficient matrix of this system of linear equations. How do we find the coefficient matrix? We represent the coefficient matrix with the letter, uppercase letter A, and we will write it as the coefficients of each of these variables. So for example, in the first equations, the coefficient of x is 1, so we will put it as 1 here. And the coefficient of y is negative 1, so we'll put it as negative 1. Coefficient of z is 2, so we'll put it as 2. In the second equation, the coefficient of x is 2, so it comes in the first column there. And there is no coefficient of y, so we have to put the coefficient of y as 0. So suppose if a variable is missing, we need to put it as 0. And the coefficient of z, we can see that it is equal to 1. So we can see that the coefficient of x in all the three equations will come in the first column, coefficient of y will come in the second column, coefficient of z will come in the third column. So now we can easily write the third row here as 3, 2, 1. And we have used the third equation to write that third row. So this is what we call the coefficient matrix. So this is what we call the coefficient matrix. The next thing we must write is the variable matrix. The variable matrix is nothing but just the three variables present and put it in the form of a column matrix. So we have it as x, y and z. And finally, what is left is the right hand side matrix or the constant matrix, and we can write it as the constants on the right hand side, which is 3, 1, 4. So this is called the variable matrix, and this is the right hand side matrix. we can observe that from the system of linear equations, we can see that a times x is equal to b. So when you multiply a with x, you will definitely get b. Now we will proceed further. The first step going forward is to find the determinant of the coefficient matrix. Now how can we find the determinant of coefficient matrix? So this, you must know how to find the determinant of a 3 by 3 matrix. Now if you don't know, you can see how it is being solved here. So I can expand a determinant along any row or a column of the matrix. So I'm going to expand it along the first row here. The first row here, I can see that the numbers are 1, -1 and 2. Okay, so I'm going to put the first element there as 1 as it is. Now to find the remaining part of that determinant, I have to ignore the row and column in which that 1 is there. So that 1 is part of the row number 1 and column number 1. So I have to cancel that row and column, and what is remaining I have to put it as a 2 by 2 matrix. So I have to put it as 0, 1, 2, 1. So what I have done is that for that 1, I have ignored the row and column, and I have put the remaining elements in that 3 by 3 matrix in a 2 cross 2 determinant form. Okay, that's the first step. So I'll have the first term as 1 into 0, 1, 2, 1. Now the second term is -1. So we should know one thing, that whenever we expand along any row or a column, we have signs. We need to put the plus or negative sign with respect to the position of the element. So this is plus, this is minus, this is plus, this is negative, positive, negative, positive, negative, positive. So since we are expanding along the first row, we have the signs as plus, negative, plus. So positive, negative, positive as the signs, and we have already put the first sign, which is plus sign, and we have done that. So the next sign is the negative sign, and the next element there is that -1. Okay, so I have to ignore the row and column where that -1 is there. So I can see that what is left is just 2, 1, 3, 1. Okay, 2, 1, 3, 1. So for that -1, I should put the -1 first and then ignore the row and column. What I get is 2, 1, 3, 1. And the next sign is plus sign, and I'm going to write the 2, and similarly I'm going to ignore the row and column of for that 2. So which I'll get it as 2, 0, 3, 2. Now to find the determinant of a 2 cross 2 matrix, it's very simple. What you have to do is you have to first multiply left top to bottom right, and then minus the bottom left to top right. This is what you have to do. So what I'll get here is 1 times 0 times 1. I have to put a minus sign, then 2 times 1. Then minus of minus becomes plus 1 into 2 times 1 minus 3 times 1. Then a plus 2 there. Then I have 2 times 2 minus 3 times 0. So in this case, I'll have 1 times anything is that bracket itself. So 0 times 1 is 0. Minus 2 into 1, I'll get it as -2. Plus 2 into 1 is 2. 2 minus 3, I'll get it as -1, which is -1 in this case. Now 2 times 2 is 4. 4 times 2 is 8. So I'll get it as +8. So when I solve this, I'll get this as 8 minus 2 minus 1, which is 5. And we have to make sure that the determinant is never equal to 0. Now in this case, it's not equal to 0. Now why this is important is because when the determinant becomes 0, we cannot solve this system of linear equations further. And if it is not equal to 0, that means A inverse exists. So that means therefore A inverse exists. Now, A inverse is important when we go ahead with in the following steps when we solve this problem. So this is the first step. We have to find the determinant and we have to see that the determinant is not equal to 0. So we have found the determinant and we got the determinant as not equal to 0, which is equal to, here in this case, it is equal to 5. Okay. So moving forward, we need to find the cofactor matrix of A. So how we can find the cofactors of each of the elements in A? So we already have, I'll just rewrite the A matrix A once again here so that it is easier for us to find the cofactor matrix. So we have 1, minus 1, 2, 2, 0, 1, 3, 2, 1. So this was our matrix A. Now how can we find the cofactor matrix? So this next step is to find cofactors of each element in A. So it's very simple. We just have to know how to find the determinant of a 2 cross 2 matrix. So I'll just make a big matrix here. It will be easier for you to understand as well. Okay, so the first thing we must note here is that we need to put the signs. As I told before, it is plus, minus, plus. There is minus, plus, minus, plus, minus, plus. And the steps to finding the cofactors of each of these element here remains the same as we did in determinants. Like we did for this one, we ignore the row and the column. So what is left is we are going to put here. So when I ignore the row and column for that element, what I'm going to get is 0, 1, 2, 1. Please note one thing here is that I am not putting this 1 here. This 1 is not taking its place here. So it is just the ignorance, I'm ignoring the row and column and then putting the remaining thing there and the determinant form. So similarly, when I do for the all other elements in that matrix A, what I get is 2, 1, 3, 1. For this one, I'll get 2, 0, 3, 2. And here I'll get negative 1, 2, 2, 1. And here I'll get 1, 2, 3, 1. 1, negative 1, 3, 2. For the last row elements, I'll get it as minus 1, 2, 0, 1. Here I'll get it as 1, 2, 2, 1. And for the last element in that matrix, I'll get it as 1, negative 1, 2, 0. Now each of these determinants can be found by multiplying the top left element with the bottom right and minus bottom left with the top right. So when I do this, I'll get each of these values as, I have 0 times 1, which is 1. 1 minus 2 is minus 2. So I'll get it as minus 2 here. And here I'll get 2 minus 3, which is negative 1. There is already a negative sign, so negative of negative becomes positive. So similarly, when I find all these values, I'll get the values as here it as 4, then this one as 5, negative 5, negative 5, negative 1, 3, and 2. So this is the cofactor matrix of A. So once we get the cofactor matrix, the next step is to find the adjoint of A. Adjoint matrix of A is just the transpose of the cofactor method. Now the transpose means you are interchanging the rows and columns of the matrix. So I'm just going to interchange the row and columns of the matrix we just obtained. I'll get it as -2, 1, 4, 5, -5, -5, -1, 3, 2. Now this is what we call the adjoint matrix. So what we have found here first is the cofactor matrix, and then after finding cofactor matrix, we are doing the transpose of that matrix and we are getting the adjoint matrix of A. Okay, we'll move ahead and we are going to find the next step. The next step is finding the inverse matrix. So A inverse. A inverse is, the formula for A inverse is 1 upon determinant of A times adjoint of A. Now this is why we told the determinant of A cannot be equal to 0, because division by 0 is not defined. So that is the the minimum requirement for finding the solution for such a system. We must have the determinant not equal to 0. So here in this case it will be just 1 by 5. Determinant of A is 5, and we just got the adjoint matrix as -2, 1, 4, 5, -5, -5, -1, 3, 2. So this is the inverse of matrix A. Now in the beginning we saw that A times X is equal to B. If I'm multiplying on both sides with the inverse, what will I get? I'll get A inverse times AX equal to A inverse times B. Now we can see that A inverse times A inverse times A is always equal to the identity matrix, and if I multiply identity matrix with any square matrix, I'll get it as same matrix X. So I have X is equal to A inverse B. So this is what I'm going to find. Our aim is to solve the linear equations. So to find the solution, that means we have to find the variable matrix. So that means X is equal to A inverse, which is equal to 1 by 5, and here I have -2, 5, 7, 1, -5, 3, 4, -5, 2, and the matrix B was 3, 1, 4. Now this is basic multiplication of two matrices. So what I have to do here is I have to just multiply the matrices A inverse and B. So I'll get -2 times 3 plus 5 times 1 plus 7 times 4 as the first term. So I'm going to multiply the first row with the first column here. So the first row with the first column, I'll get -2 times 3 plus 5 times 1 plus 7 times 4. And the same thing with the second element there. So I have 1 into 3 minus 5 times 1 plus 3 times 4. Same thing here, 4 times 3, -5 times 1 plus 2 times 4. And when I do this, I'll get the values as -2 times 3 is -6 plus 5 plus 28. beg your pardon, here the value was not 7, it was -1, so it should have been a -1 there, and so here it should have been -1. So I'll get the value as -4. And here the same thing, 3, -5 plus 12, 12 minus 5 plus 8. So I'll get the x values as 1 by 5 times -10 plus 5 is -5, 10, 15, and when I multiply 1 by 5 with each of these elements, I'll get the x values as -1, 2, and 3. So that means my variables x equal to -1, y equal to 2, and z equal to 3. So this is how we solve a system of linear equations using matrix method. If you like the video, please give a thumbs up and please subscribe. Thank you.